Hey guys, Anishi PyMasters Scholars here. So today we'll be implementing a queue as a class. So we've already learned how queues are best implemented in Python. They're implemented through a data structure called a deck from the collections module. And a deck is basically just a double-ended queue, but when we're trying to implement it as a queue, not a stack, we only use the left side. So the first element that will be added into the deck is also going to be the first element of our queue, or the front of our queue. So it's going to be the first one that we pop off, the first one that we remove or access. So we already know the methods that a deck uses. Now we want to customize that for our own queue class. So we want to create our own queue methods, and then also our own toString method. So whenever a queue is printed, we can customize exactly how it's printed to the screen. So whenever we print a deck, by default, it's going to show the word deck and then parentheses and then the elements inside square brackets, but we don't want to show deck and then the parentheses, we just want to show the square brackets and the elements inside of it because it looks cleaner, it's more clear. So that's why we create our own queue class in order to customize the methods that we can use to manipulate the queue. So first off, we are going to be using a deck as the backbone for our queue class. That is how we're going to be storing the elements in our queues, by using a deck, because decks are efficient when performing queue operations, like removing from the front or adding to the front. So first, before we create the queue class, we have to import the deck class from the collections module. So from collections, we have to import deck. Now we can create our queue class, so class, and then we'll call it queue. And then inside our queue class, we're going to need a constructor. So define underscore underscore init underscore underscore, and then we need a self reference, and then we use that self to create our instance variable. Our instance variable is going to be an object of the deck class. It's going to be a queue, and we're going to call that instance variable queue. That's equal to an object of the deck class, so deck parentheses, and then we're going to create our methods for our queue class. So the methods that we want to create are going to be adding. We're going to be removing, so we can use pop. And then the next one is peeking. So if we wanted to access the front element of the queue without actually removing it, we can call it peek or front. We'll call it front for clarity. If we wanted to access the back of our queue or the last element added to the queue, we can use the back method. And then we can have a size method as well. So you can choose which methods that you want in your queue. But the main necessary ones are going to be adding, removing, peeking, and then likely getting the size as well. So we can start with our add method. So we can define the add method. The add method should obviously take in a self-reference because we need access to that instance queue. And then we also our second parameter should take in whatever value that we're adding to the queue. So we'll call that value number. And then we're going to add that number into our instance queue. So self.queue.append, because remember the deck class allows the append method, has the append method to add elements into the deck. So self.queue.append, and then the number that is passed in as the argument. And then we can also define our next method. So we'll define front. Front should also take in a self-reference. And then for front, we're just going to return the first value in our deck. So return self.queue, and then at index 0. Index 0 represents the first value in our deck. And then we can also implement the pop method. The pop method also takes in a self. And the pop method should remove and return the element at the front of the queue. So in order to remove and return an element at the front of a deck, we use the pop left method of the deck class. So self.queue.pop left. So that what that will do is that will remove the element at the front of the queue and also return it. So that this pop method right here that we're defining will also return whatever element was at the front of the queue. And there's also we can also use back. So back is an optional one. If you want to access the back of the queue, then we can just return kind of like front self.queue and then index the last element. The last element of a deck is going to be at index -1. and their size. So we're going to define the size method. We're going to pass it self-reference, and we're going to return the length of the queue. So self.queue. We can use the len function to get the length of a deck. And then the last thing that we're going to implement, so this is the most tricky method right here, and it's going to be the toString method. So whenever we print the queue, whenever we print a queue object, we want to only print the square brackets. And then inside the square brackets, we want to print the elements separated by a comma. So the elements from the front to the back of the queue, separated by commas in between them. So in order to define a toString method in a Python class, we'd use define underscore underscore str underscore underscore, and then pass in the self. So now how we actually figure this out. So decks are not iterable in Python, meaning we cannot use a for each loop and access every element. So what we have to do instead is we have to process each element from front to back one by one. So we have to keep popping off the front, printing it, popping off the front, printing it until there are no more elements left in that queue. But the issue with that is that it's if we if we do that for our deck right here, we're going to empty out the deck, so there's going to be no more elements left in the deck because we're constantly removing the first element, printing it, and then we keep removing all the other elements until there are no more left. So then when we want to use that deck for another method, there's going to be no elements in the deck anymore. It's going to be completely destroyed. So we want to keep that deck safe, and we want to copy the elements of that deck into a new deck. And in order to do that, we can just create our own temporary deck. So we'll call that variable temp, and that's equal to a deck object as well. But for in the constructor of that deck object, we'll just pass in our deck, our current instance deck right here. And then this temp deck is just a decoy deck. It's just our own. It's just a temporary deck that copies or it stores the elements of our instant deck. And then any modifications to that temporary deck is not going to affect our instance variable deck right here. So now we can just perform anything that we want to on the temporary deck. We can remove all the elements. It's not going to impact the actual instance queue. So um, so what we want to do first is we have to build a new string. So toString can only return a string. It doesn't print anything. So we have to build our own string. The string that we'll just call that q, represent q, and then that's just going to be equal to currently it's going to be an empty string, and then you want to add an opening bracket actually, not just an empty string, because in our elements need to be enclosed in square brackets. So right now we'll have an open bracket in there, and then we're going to go through. So while we're going to go through our temporary deck, so while the length of the temporary deck, while that's greater than 1, and the reason why I'm doing greater than 1 is because I'm going to be adding commas after every element that I add. I'm going to be adding commas after every element that I add into my Q string right here. And but I cannot add a comma after the last element because there's no more elements after the last element. So there's going to be a floating comma there, not separating anything. So what I'm going to do is I'm actually going to remove and add all of the elements except the last element in the queue. And then when there's only one element left, that's when I stop iterating through. And then at the end of my loop, I'm just going to add that element into my final queue without a comma, and then add the closing square bracket. So right now we're going to add to our queue. We're going to concatenate to our queue string the current front of our queue. So the current front of our queue, and then we also have to return and remove that front of the queue. So queue plus equals, and then temp dot pop left. So that's going to return the front of our queue, and it's also going to remove it so that when we repeat this iteration, we're going to then remove and return the next element in the queue, or the next front of the queue. And remember, this is going to return an integer right here, pop left, and we're concatenating that to a string, so we have to cast that to a string, an str data type. And we have to add a comma after it with a space. And then when there's only one element left, that's when we will just add to the queue that one element left. So string temp.pop left, which is the last element, we can just access by doing pop left or index 0. And then we're going to add the closing square bracket after that. And then we're going to return that final Q. So now we've completed all of our methods, so now we have to test our Q class. So how do we test our Q class? What we're going to do is we're going to first create a Q object. We'll just call that Q object Q, and then that's equal to an object of our Q class with an empty constructor because our constructor is empty up there. And then we need to get user input. We need values to add to this queue. So we're going to ask the user what values they want. So we'll first tell the user that their queue has been created. And then we're going to get user input. So we want to know what value they want to add to the queue. And then we have to keep prompting them to add a value to the queue until they don't want to add any more. So what we can do is we can first prompt them to enter a value to the queue. So input, and then enter your first, or enter the first value of your queue. And then whatever they enter should be an integer. So we're going to use the int method here. So whatever they enter is going to be automatically taken as a string because the input method, the input function returns a string. So we're going to cast that to an integer, and then we're going to store that in a variable called element. Element is equal to. And then we're going to keep doing this until they enter -1. So until they enter some integer, we'll just choose a -1. So while the element is not equal to -1, so while whatever they enter is not equal to -1, then keep prompting the same thing, and then add whatever they enter to the queue. So we can use q.add element, and then prompt them again, and change the assignment of element. So assign an element to the new thing that they enter, and change the prompt to ask enter the next value of your queue. And then once this loop ends, that queue should have already been filled up by whatever the user wanted to add. So then we can print the queue and see if it matches. So we can run our code here. So we can fix this prompt right there. Just add a colon and a space so that they have space to type. Okay, so we'll enter 1, then 2, then 3, and then 4, and then 5, and now when we enter -1, it should stop, and then it prints out the queue that we've entered just with square brackets and then elements in between the square brackets 1, 2, 3, 4, 5. And then we can test if our popping and our size and our back and front are working properly. So we can print out popped element. And then the popped element should just be equal to the queue's pop. We call the pop method on the queue. So that should just be equal to the front of the queue. And we can print the new queue. Queue after pop. Print the queue. And then we can also print the new front of the queue. So new front of the queue. And the new front of the queue should just be equal to the queue's front method. And we can see if that works. -1. All right, so the popped element here is 1, and that's correct because 1 is at the front of our queue. Popped element is 1, and then the queue after the pop should just be the queue, which was originally 1, 2, 3, 4, 5 without the 1. So yep, it does have 2, 3, 4, 5, and then the new front of the queue is just the first element of that queue, and then that is 2. So yeah, our queue method or our queue class does work. All of our methods work properly, and our toString does work properly as well.